cadence and this kind of. This is really impressive. I'm not saying that to butter anybody up. I promise. This is genuinely just
4 minutes.
me
FTS
impressed.
Confirmed. FTRs are active and range is transmitting check channel 4.
Confirmed. FTRs are active and transmitting check channel.
FTS, send ARM enable 1 command to all ESADs.
ARM 1 sent.
FTS, send ARM enable 2 command to all ESADs.
ARM 2 sent.
FTS, confirm that all ESADs are enabled.
FTS confirms all ESADs are enabled. Fly safe.
You heard it there, guys. FTS is enabled, so flight termination system is enabled. They are going for launch. We need to do one more thing here at Everyday Astronaut. We have a little tradition.
Confirm your monitoring fuel bleed.
We need to check that the pointy end is up and the flaming end is down. Let me tell you guys, I've had a good amount of time around this vehicle. I can confirm from our end that the pointy end is up and the flaming end is down. So that's confirmation for me. There's the pointy end, and there's the flaming end. Boom. Pointy end up, flaming end down. From our end, us casual observers, this thing looks good to go. You can see
3 minutes, fuel bleed is starting.
Fuel bleed, so you can see the engine's getting ready to cool down to be able to.
Go, no-go at T-minus 2 minutes. Any no-go at this time is an automatic abort.
This is prop. I can confirm flow and fuel bleed.
Copy, thank you. I believe we hold this for 90 seconds.
Vehicle will de-energize.
T-minus 2 minutes. This is the final commit for launch.
This is a very big thing here. That
Started.
T-minus 2 minute poll.
Line 3. Line
Chief engineer,
Send it.
launch director,
Go for launch.
rock,
Range green.
12.21, confirmed, buying off. T-minus 1 minute and 50 seconds.
I can't believe this. They're going for it already. Like, how are they doing this? I mean, we are T-minus 1 minute 30 seconds. We're looking go for launch.
T-minus
I
130.
can't believe this. Trying to do a little extra bonus cam action here for us.
Close alarm.
Abort, abort, abort. We have these two PHSs at 1700 PSI.
Abort, abort, abort.
Aborting.
You heard it, guys. We have an abort. We will stand by for more information on why that was.
Taking abort actions at this time.
So they do have a 4-hour launch window here today, so don't call it
Confirm there are
yet.
no fires on video.
Confirmed.
GC, please stop. Please close NV 598599 Alpha Bravo. BC, confirm the following prevals are closed.
Confirmed prevals are closed.
Helium bubble is active.
Bubble is active.
S1 fuel tank is maintaining between 30 and 36 psia.
Confirmed.
Verify all other tanks are vented.
Confirmed.
GC, please verify the T-type tank is vented.
T-tip tank is not there.
Confirmed.
Is it below 100? We'll keep...
T-tip.
Go ahead. Please open TV 605.
TV 605 open.
Verify that the TVC tank is vented.
It's empty.
Verify swim system is vented and cavity purges are active.
Is it boost?
BC, please verify the C-REO is in the release safe state.
Sounds like a first case.
BC, please confirm C-REO is in the release safe state.
Is it boost?
BC, please verify the C-REO is in the release safe state.
Sounds like a first case.
BC, please confirm C-REO is in the release safe state. I have save on the.
So you guys are hearing there. We are. You guys have heard that they have gone for they've called an abort, but again they have a 4-hour launch window here. So that was right at the top, right exactly at the top of their launch window. They called an abort, and actually, again this is only their second launch attempt ever. So there's a chance they have an opportunity to reset, and hopefully we still have a chance to fly today. We will await a new T0 time here for you guys. And we will get you guys updated on that as soon as we know anything. But currently, we are back in a hold, which means our teams here get a chance to breathe a sigh of relief because we are definitely running the scramble game. But yeah, holy cow! I thought, oh man, my heart was racing. My heart was absolutely racing. So this is an opportunity. This is what's fun about these kind of streams is that we get to tell you guys, we get to chat and hang out because after all. Spaceflight is a bit of a spectator sport for some of us here. We get to enjoy rocket launches, talk spaceflight history, talk aerospace, talk rocket science, and I get to kill time with my friends here as we learn what exactly is going to be happening here. So, yeah, again, we are just awaiting more information and what's going to happen today in today's 4-hour launch window. So, again, thank you all. If you are watching, please continue to watch because. Hopefully we'll learn more about today's launch attempt, see if there's another opportunity in this window. But also, you guys, this is a really exciting opportunity for this launch company. And I know it means the world. They literally have so many employees have come up to me and just said how excited they are to be able to share this with people and how much it means that people are watching the hard work that they get to do. I mean, I know I'm just simply a conduit to be able to provide this stuff to you guys. But really, you guys watching and cheering for this company just really means the world to everyone working on this vehicle. I've just had the opportunity and the pleasure of meeting so many people, and they all say that they're so excited that we get to share this with the world. So let's hear it. Just give a hand for them for aiming for minute like T0 right at the top of their launch window. A date that they've had in the books for months. That's impressive. That's genuinely impressive. So, yeah, thank you again to everyone for watching. Hopefully we learn more and more here, and we'll update you guys as soon as we can. But meanwhile, we want to give you guys a few extra questions here. So this is from Budarowski saying, Tim, what's the difference between the Firefly Alpha, Beta, and the new Antares first stage? Thank you, Tim. So right now, the Alpha is the only rocket that they're flying at the moment. This is their first rocket. This is their opportunity to learn a lot on a little bit smaller scale. The Beta rocket will be a lot larger, and its first stage is virtually the same, at least at first, as Antares, and it uses much bigger tap-off cycle engines called Miranda engines, and so it's going to be a much larger vehicle, much more powerful. So it doesn't even share the same exact engines, but it does share the same engine technology, being that it is tap-off. So. Yeah, so I don't know yet if we're going to see it first on Antares or if we're going to see it first as the Beta rocket. I don't know. I'll try to learn about that because that's going to be really exciting. I mean, seeing how developed this system is already for its first attempts is awesome. So I can't wait to see them scale up and continue doing big things. But the cool thing is they definitely are wanting to fly this rocket and continue flying it alongside of even larger rockets because there is a demand for this larger, for this small sat rockets, but having a little bit more capability means they can fly, larger small sats and even be able to use them in tandem where we can literally launch like say 2 or something and still have a dedicated ride to very unique and particular orbits. That is a capability that ride sharing can't do. So they think there's a nice niche there. A lot of people think there's a nice niche there. There's a lot of upcoming rocket companies working on this exact market. So they think, by all accounts, that they'll continue flying Alpha even when Beta is flying, and even as they continue to support Antares as well. So, are there onboard cameras on this rocket? Yes, there are. There are cameras on board the rocket, and yeah, that's something that's obviously pretty cool. We aren't able to show all of them, but we can show some of them, and at particular times we'll be able to do exactly that. So, yeah. This is from Corey S. Thank you so much. I appreciate your chat saying, welcome to Cali, Tim and crew, pointy end up, flaming end down. it's so fun seeing that that we actually have the cameras out here to really give you a good confirmation. Yeah, how cool is that? Let's see. Yeah, this is, I love, thank you so much, Mike Jennett. This great broadcast, Tim. Big shout out to Firefly team for all the hard work at Astra. 100%. Again, space is not easy, and we're seeing them knock it out of the park so far, just even getting this vehicle on the pad and fueled up and going for a launch attempt this early on. Very, very impressive. This is cool. I love seeing these kind of comments. This is from, I'm going to totally not say this name correctly, but Wissiv Rees says, "Hi, Tim. Thanks for inspiring me to pursue a degree in aerospace engineering." That's what this is all about. That's what Everyday Astronaut's all about, bringing space down to Earth for everyday people. It's just helping you guys get excited about this stuff. For me, like, literally, if I didn't have a YouTube channel and a weird van that does 4K broadcasts, I'd be out here just totally nerding out. I would have probably a same tent and or an umbrella and a lawn chair, watching rockets fly and just screaming at them by myself. This is my opportunity to be able to share this with you guys. Hope you guys come along for the ride and hopefully enjoy this as much as I get to enjoy it, which is an immense amount. This brings me so much joy. Seeing a rocket fly is one of my absolute favorite things. But what's even more exciting is when you learn how they work. When you learn some of the details that engineers get to, the problem solving they get to do, the little bits here and there of like all the little secrets of you know, even like things like liquid oxygen. It's just insane to me that there's fuel on board this vehicle that's so cold. You know, if you went up and touched the side of the rocket right now, your hand would like stick to it because it's so cold. Just all these amazing facts and things about spaceflight get me excited, and the more I learn, the more I appreciate the how hard people work and how brilliant people are. There's humans out there that are just so insanely brilliant I can't even comprehend, and to be able to problem solve and make it so you can put things into orbit, just simply crazy. So yep, it's my pleasure. I love hearing that people are out there you know, looking for and working on degrees in aerospace engineering and things like that. Really makes me smile. So thank you for saying that. Yeah. So this is actually really cool, Thomas. This is a fun little thing. You'll see on the screen right now is an A for alpha. The next letter next to it, there's an L. Then there's a P. Then there's an H on the four things. And if you keep going, it goes back to A. So it actually, if you go around the rocket, it actually says alpha on the four engine covers there. Fun little Easter egg. I think that's super cool. Yeah, which I just think is awesome. So the teams have had a lot of fun with that as well. So yeah, let's get to a few more. Again, thank you for those of you that are, you know, super chatting and doing members. I really appreciate that stuff. That really helps us here at Everyday Astronaut be able to provide you guys this kind of coverage. And you know, thanks again to the teams at Firefly for trusting us. I'm going to try to keep things a little bit more on topic-ish since this is Firefly's live stream. But just know from the bottom of my heart, it really means a lot that you guys are tuning in, and the support goes a long ways and makes this stuff possible. Because yeah, it's gas prices these days, driving across the country is definitely expensive. So it's just this is an opportunity that we absolutely could not pass up, though, to be able to put cameras on a launch pad with a rocket on it that's about to take off. I mean, 4K, come on, it just doesn't get better than this. So you have to do it, right? Let's see here. This is a good question. This is a little bit topical here, but we'll take it anyway. From Troy Hammond, thank you so much, saying, "Hey Tim, are you planning to head back to Florida to cover Artemis again?" Yeah, we definitely want to. We definitely want to. You know, obviously the Artemis program and the SLS rocket is incredibly exciting. It's the most powerful rocket on a launch pad, I guess, ready for flight. I'll put it that way. I don't want to start a flame war here about what's the most powerful rocket, but we'll say it's the most powerful rocket that's ready to fly-ish. But I can't wait. I cannot wait to see that rocket. You guys know that that you know, we've worked really hard to provide coverage for the first couple of launch attempts of Artemis. As soon as we know more, the teams at NASA are working through some issues to see if they can fix some of the leaks in the system, and I think they're going to be testing that like the 17th and or the 18th or something like that, and they're go for another opportunity to fly, I believe, starting the 23rd. So there's a small chance this van will be going right straight back to Florida. Personally, and that was a selfish thing, I hope that it scrubs until the next launch opportunity in October, so we can have a little bit of downtime and not just be a full-time like touring van thing. As much as it was fun to be on the road and get out here in a real hurry, that still was definitely pushing timelines. So This is from James Anderson. Do they shut off the liquid oxygen vents prior to launch? If so, how much time do they have till the tank's over pressure? So you'll notice that on rocket launches, those vents are always active and they're regulating the pressure, because even as they begin to drain the tanks, and as they're being backfilled by helium, or in some rockets, autogenous pressurization, so still using gaseous oxygen or gaseous methane or gaseous helium to backfill the tanks, you still need to maintain proper tank pressure. So sometimes you will see venting, and actually watch slow-mo videos of rockets, you'll almost always still see venting coming out of vent port on ascent. So that's quite normal, and it's just a way to maintain it and continue to have the pressures be perfect. I don't know if any of them would ever totally close entirely, because I think it's just kind of a ongoing modulation, so a dynamic thing. So, oh, this is fun to see. I got to do this. I'm sorry. When I see stuff like this, can I give a shout out to Jordan Y from Texas, who works at Firefly and helped manufacture the rocket. I can't do too many of these because there'll be a million, but this one made it into our chat. So from Ashley Davis, Jordan Y, big shout out from Ashley Davis. And I got to just say again, shout out to the teams at Firefly. It's been so fun to see them work on the vehicle and get this thing ready to fly, get this whole system put together. And again, seeing their facilities out there in Austin, Texas. Both their main campus is incredible, where the engineering happens and their mission control and things like that. But Briggs is where, so in a previous life I used to work on cars and motorcycles a ton. And going out and seeing Briggs where they're building and testing, like these are people in like machine shops just getting their hands dirty, literally working on space flight things, and I think a lot of the people, I've talked to different people that a lot of them did come from like the automobile industry, come from racing and things like that, having racing backgrounds, that went from precision manufacturing, precision tooling, and precision mechanic work from cars and high performance vehicles to even the most, in my opinion, this is about as high performance as you get. A vehicle with thousands of horsepower. I mean, come on. This is about as cool as it gets. I get the bug when I walk through a factory like that and I walk through a machine shop like that. I get the bug. I want to tinker. I want to help build and things like that. I got to say, it's very inspiring. If you are someone looking for a job, this is not they're not telling me to say this. I promise. This is just me. I would go out there and I'd be looking in LinkedIn for some positions. I know that Firefly's got some positions available. If you're looking for a job, I think these guys are hiring. They've got a lot of really impressive things on the horizon. I mean, they're going to the moon. I don't know if you guys know this. They're literally landing a lunar lander in about 18 months with NASA. It's actually riding on a Falcon 9. It's their Blue Ghost vehicle. Super cool. I had the opportunity to speak with Shay the other day, who told me a little bit about that. I have a video that we'll hopefully be able to post here in a little bit. We ended up having so much time setting up this live stream that we haven't had an opportunity to post the video yet. But I got to speak to a couple people and learn more about some of the things they're working on. They're working on really hilariously big things. Like, this is a company that I think a lot of people kind of went under the radar. And then all of a sudden, the last, 6 months, it's like, holy cow, these are some really big and exciting things. Yeah, just a little shout out. I'm just excited. Let's see. This is, okay, cool. Randy Wiedenfeld says, just got the metal Falcon 9 that we have in our web store. Thank you so much, Randy, for your support and your patience. I love seeing these shipping out. That makes me so happy. How soon will we get more? I would love a smaller rocket for true size comparison. So, yeah, so we have 1/100 scale model rockets that we did our first run of. After some manufacturing woes, we got new parts in, and they are shipping to customers. I've been seeing a handful on Twitter. It's so cool to see these in customers' hands. And that's the first of hopefully just a whole fleet of rockets. The biggest point for me is I wanted them to all be the same scale. It's so weird to me, like the common scales for model rockets is like 172 and like 177, all these weird scales. It's like, no, make it 1/100th, and I want all vehicles to match the same scale. So that being said, I decided that that's exactly what we're going to be doing. So the Falcon 9 was our first rocket that we put on in the store and made. Hopefully next, I really would love to do some small sat launchers. I mean, seeing Firefly's Alpha next to some other rockets and other small sat launchers like Astra's rockets and the Electron, Rocket Lab's Electron and Launcher, all these exciting new rocket companies. It'd be really fun to see them in size comparison, because There's a whole, I mean, you could basically make a perfect gradient of size of all the vehicles that are out there today. There's just, they come in all shapes and sizes, and it's really fun. So that is the goal someday, just have this huge collection that we can get out there for people to be able to pick out their favorite rockets. And yeah, and again, seeing this vehicle out on the pad, compared to the Delta II was a very small medium lift launcher. It was right at the bottom end of the medium lift launch capability. Half the time it flew like small sat payloads, basically. But it's been fun because that's the only other vehicle I've ever seen out here on the West Coast. And this rocket is, frankly, a lot closer in size compared to that than a lot of other small sat launchers. It's a very, very large rocket. Again, maybe we'll take this opportunity. Can we throw up those graphics again? Because I do want to remind people of how big this thing is. It is about 30 meters tall, so quite large in this small sat game. 1.8 meters wide, so 6 feet wide, and that's a big rocket actually for a small sat launcher, which is why it has such high performance as well. So this I like seeing this from L Motorsport fans saying, how meta is it that I'm sitting here working on designs for a satellite bus while watching this live stream? Thanks for the amazing coverage. That is, I love that. Again, it's just so cool that we have this generation of people that are watching this stuff in real time, casually in their living room. We're getting we're getting shots like this. We're getting footage from all over the place from a ton of really exciting things about rocket launches that we just didn't have this kind of access previously. So it's so cool that this is becoming a bit of a spectator thing, that people are joining in and getting excited about this stuff. So, all right. Let's see. This is T. Burns wants to know, what's the purpose of Firefly anyway? This is the first time I've heard about it. Well, there's a race, my friend. There is a race to fulfill the needs of customers. There's so many new startup companies that have payloads that are trying to get to orbit. I mean, there is literally like a laundry list, a backlog of countless payloads that are trying to get to space, because a lot of people have new ideas, new demonstrations, new ways to communicate, new ways to observe, new ways to look at the planet and study things like climate change and weather and track hurricanes. I mean, I can't even tell you how many people are out there literally working on satellites that are still trying to find a way to get to space as quickly as possible and as cheaply as possible. So the race is on still for a new crop of payload payload services. So that's exactly, Firefly is positioning themselves to be a staple in the launch industry. So, basically think about it here in the U.S., the most common, there's USPS, the Postal Service will deliver your packages, but there's also, of course, FedEx, and there's UPS. Globally, there's a handful of companies that deliver a package to a destination. And, they're competitive with each other, and you have multiple solutions. There isn't just one out there. And that's the exact same thing. These things, there's payloads that need to go to space, and people pay someone to get them there. They're the UPS truck, they're the big brown truck getting things into space. And the race is on right now to be the first to be able to provide those services. So, yeah, Firefly can certainly fulfill those services for a huge crop of vehicles. So, yeah, super cool. Let's see here. I'm actually going to probably take a little bit of a break while we wait for an update here from the teams. We're going to leave you with the rocket on the pad here for just a little bit. But I hope I'll have a lot more time. We do have a 4-hour launch window to be able to get you guys. Hopefully we see a launch today, because this is amazing. This is the nicest day we've had out here. So we're really hoping that we do have the opportunity to see a launch today. So stand by as we get more information here from the teams. But I'm going to take just a quick little fiver, but we'll leave you guys with beautiful views of this rocket in stunning 4K. We'll be right back. And I'm back, ladies and gentlemen. And if those of you that didn't read the little thing where my face now is, if you couldn't tell, and if you haven't checked our T0 time, we do have a new T0 time. So the teams are going for another launch attempt in today's 4-hour launch window. So the local T0 time is actually 4:20 Pacific Daylight Time, PM, which is 42 minutes, and I'm going to wait for it. And 42 seconds from this exact moment. Lots of 4s and 2s. Mary Liz Bender's going to be very happy. Anyone else that's a fan of Hitchhiker's Guide to the Galaxy, that's got to make you happy. So yeah, we're 42 minutes away from the next launch opportunity of Firefly Alpha. Look at again, take a moment to just gander at how beautiful the sky is. I really hope this thing takes off. And the later in the day we get here, the more beautiful that blue sky gets. I think, you know, the rocket just might... We don't actually have any official word yet on what caused the scrub, but, you know, they were getting quite close in the terminal count. So as soon as we have information on what caused that scrub, we will update you guys. But the good thing is, you know, maybe it was just the rocket wanting to put on a better show and be in prettier light. That's at least the photographer and me speaking. That's probably exactly what it is, at least on my end. So how have you guys been? I hope you guys didn't miss me too much. We shifted some stuff around here because the sun is starting to get lower and lower out here in California. So we're starting to get more and more heavily shaded. Or I wanted to make sure I was in the shade and not getting too sunburnt. All right, so let's go ahead and answer a few more of your guys' questions here. Let's see. So yeah, as you see too in our little prompt here, after the first abort here, which was 38 minutes ago, the teams have been able to get another new T0 time for another launch attempt at 4:20. So really exciting. It gives that gives me a sigh of relief, honestly, because I feel like it came up out of nowhere for us. Like I feel like we were all ready to go, and all of a sudden we're in the last like 3 minutes, and I'm like, oh my god, I don't know if I'm just ready for this. You know, this is good for me. I don't know if they did it for me, and again the lighting, but I don't know. I'll stop talking. Let's see here. Let's look through a few more. Let's see. I don't really want to get into too much speculation here from people, so actually, I have a fun thing. We did have a lot of questions, and I've realized honestly the best way to answer some of these questions about this vehicle is to actually just go to a little website. I do this trick a lot. A little website, but this time it's not everydayastronaut.com. This time it's firefly.com, and clicking on their alpha link. Their website's amazing, but they actually look at this. They even have a way to be able to see the inside of their engine and of their rocket and stuff like that. So I actually forgot the payload of this vehicle. The payload capability is over a metric ton, 1,170 kilograms. Like I said, this is at the upper end of a small sat launch vehicle. That's like getting awfully close to medium class. Which please remind me, chat, or if anyone has information. I forget what where that officially starts. I don't remember if it's 2,000, 2,500, or what it is to get into medium class, or maybe it's 4,000. I don't actually recall off the top of my head. But that's definitely in the upper end of the small sat launchers, especially in this new crop. And that's on a 28.5 degree inclination. So that'd be like if you're launching from Kennedy Space Center, that's how much performance it'd have. If you're launching to SSO, so sun synchronous orbit, or a polar orbit, that does decrease to 745. That's normal for all rockets to take a performance hit when they're not flying, straight due east. They're not taking into account the full rotation of the Earth. And like we said, today's mission is actually flying retrograde. So it's actually flying beyond SSO, so backwards, dude, in relation to the rotation of the Earth. So that's 745 kilograms. Again, today's flight has about 35 kilograms on board, so you can tell they're definitely not putting a ton of payload onto this vehicle for its inaugural orbital flight. So yeah, again, this website is amazing. I can't recommend if you want these stats on this vehicle. And again, 322 seconds of specific impulse in a vacuum is pretty impressive for a tap-off engine. So yeah, and same with almost 300 for the Reaver. So that extra expansion ratio, the longer nozzle on the Lightning engine in the upper stage, does allow it to be a little bit more efficient in the vacuum of space. Pretty cool. So yeah, that's, again, shout out to that website, firefly.com, and then click on alpha or /alpha. You can get all those things that you've been asking me about, and hopefully that helps. That's a good reminder for me. 1170 is its payload capability. Again, pretty impressive. So All right. Yeah. So again, we're basically at this point just awaiting more information, and hopefully we receive an update from the teams here relatively soon, and that will give us some information on, it, maybe we won't receive an update on why exactly they scrubbed, but the important thing, the most important thing to me, is that they're go for another attempt here in 37 minutes. So yeah, this is again, thanks to all of you that have become members. That have, just helped with today and asking really good questions. We'll take to air whatever we can with your comments and stuff like that too. So thanks to all of you who make that possible. I gotta say thanks to people like 55 Chevy Guy _ Steve. Thanks for the great coverage and informative videos. You are so welcome. Again, this is absolutely not a one-person job anymore. This has turned into a whole team of people that are helping provide this coverage. So it's just I'm so thankful to have people working so hard along with me that make this stuff possible. And yeah, our team for this mission in particular, and also for the Artemis launch attempts, it's just huge. It's a whole crew of people. It's so funny. I never thought I'd be borderline running like a production company, but here we are. Here we are doing basically exactly that with some state-of-the-art equipment. Again, we've got some awesome cameras out here on base. A lot of 4K, obviously the 4K pad cameras that are also going to be recording some slow-mo footage for you guys, but we also have some awesome tracking equipment here. We'll be able to provide you guys with clean feeds of the ascent of this Alpha rocket. It's going to be super fun. As soon as that thing comes up over the mountain, it's going to be quite the shot. You can basically only see our bright orange tent there in that shot, but you get the idea that we are here with lots bright orange. That's pretty obvious where the everyday astronaut team is when you see bright orange. So, all right, let's see. This is from. We do have confirmation that weather is go for this new cycle too. So the teams have been tracking weather a little bit. There's been some iffy weather, dodgy weather, potential for cloud violations and things like that. Because don't forget, there's actually there's actually a hurricane that just recently off the coast of southern coast of California, and there is some weather that's different and unusual around here. So they're definitely having to track that, and they need to have good visual tracking for this rocket. So we're lucky enough to have really blue skies right here today. It's really quite exciting. Yeah, so let's see here. Let's keep answering a few more of you guys' questions. And again, thank you to people like Jerwa that just became a member. Really appreciate that. Let's see. So this is a good question actually from Gerardo Neva. Thank you so much again for your generous donation as well. Why are these newer rockets more powerful but less impressive at launch than the space shuttle, for example? So far, I'm trying to think. I don't think I've ever seen a rocket that's more powerful than the space shuttle. If that helps answer your question, because the statement was, why are these newer rockets more powerful but less impressive? I have not seen a rocket fly that's more powerful than the space shuttle yet. And SLS likely will be the first rocket that I see fly that is more powerful than the space shuttle, because it has an extra, about 25% more thrust out of its solid rocket boosters, and it has 4 RS-25 main engines on its core stage as opposed to 3. So it is basically just a more powerful version of the space shuttle. But Falcon 9, much less powerful than the space shuttle. Falcon Heavy is I can't remember right off the top of my head what that was. Can you repeat that too, by the way, Andrew? Oh, okay. Okay, cool. So we do have a statement on exactly why they scrubbed the first opportunity. They basically had a drop in stage 2 helium supply pressure, but they are moving into recycling operations. So what that means is these vehicles have helium that keeps the tanks at pressure. We've talked about a few times on the show now today that the tank pressure is an extremely important thing, because you have a lot of dynamic systems that are all at play here, and especially when the rocket starts to fly, you have liquids draining out of a tank. But obviously that could create a void. You have to backfill with gas, gaseous propellants or a gaseous inert gas. You have to backfill as the liquid drains out of it. Imagine if I took this bottle of water and if I turned it upside down and let it pour out, there's going to be air needs to fill those gaps of where this is not sponsored by Smart Water, by the way. The air would fill the gaps of the water bottle, and you'll see that if you're pouring water out, it'll glug, 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 glug. That's air shooting back up the system. That obviously isn't going to be happening when something's being pumped, forced out of a tank. You have to backfill and provide gas back into those regions so the tank maintains pressure, so you don't have the tank getting like crushed or anything like that, because that's actually what would happen if you drained it without backfilling it. So they backfill it with helium, and helium is good for a few reasons. Number one, it's inert, meaning it will not react with the fuel or the oxidizer. It will not cause any problems with combustion. And the number two reason is it's extremely lightweight and undense, and so it's easy to pack a lot of it into a small COPV, or a composite overwrapped pressure vessel, which is a high. They put these tanks under very high pressure, and that allows them to be able to stuff just an insane amount of helium in these little tanks, and then they can just vent a little bit of it out, and because it's so sparse, it expands it and can fill these voids, and that's why helium is used for that most often. There's also sometimes they'll use nitrogen as also an inert gas, but it's not. You can't compress it as much and make it fill those voids as easily. So yeah, so that's actually a good thing. You do want a sparse gas when you're trying to fill a large volume. You might know, hydrogen tanks, for example, on say SLS or Delta IV Heavy or previously the Space Shuttle. The hydrogen tank was huge because per mass, the volume it takes up is huge. So those tanks are just massive in order to have the same amount of mass in your tank. So lightweight molecules take up a lot of space, and that's a good thing for your backfill. So that's basically what happened. Yeah, so they had a stage 2 helium supply pressure, and they are that's what they're recycling it and reworking. So yeah, that's good. Like we said, we're down to T-minus 31 minutes basically. So obviously the teams are moving to try it again. You do see, by the way, in this shot, you guys can actually see some white patches on the outside of the vehicle where liquid oxygen is stored. You can see just a little bit of white ice buildup. I'm not entirely sure, to be honest, why the whole vehicle isn't frosty white at all times. Maybe it's too warm out here, but you can see it there in that shot, which is pretty cool. So let's see. This is again from Cadber wanting to know a little bit more about the tap-off cycle. We have talked about it a handful of times. I definitely have to say, if you guys want to learn more about the tap-off cycle, I promise you, if you watch, I have a video titled "How to Power a Rocket Engine." It's all the different rockets, the cycle types of rocket engines. So things like pressure-fed, monoprop, bipropellant, hypergolic bipropellants. And you go into pump-fed, you go into electric pump-fed, and gas generators. You go into closed cycle. You go into fuel-rich and oxygen-rich closed cycle, or you go into full flow. But tap-off and expander cycle are two other types of cycle types. And what's unique about tap-off is that they literally basically take the high-pressure hot gas that's inside the combustion chamber, and they divert that gas into the turbine of the turbine is what powers the pumps. It's basically, I don't know if you're familiar with a turbocharger in a car. You basically flow the exhaust gas of each cylinder bank. It's pretty hot gas. It's high-velocity gas. You force that through a turbine that spins a turbine up, and then you dump that out, and then that is connected on a shaft to a compressor wheel. That compressor wheel then forces more air into the engine. This is similar, where it's taking a turbine, and you're basically taking some of the exhaust, some of the high-pressure hot gas that's inside the combustion chamber. You're shooting it through a tube at a turbine. That spins up the turbine up to high, like 30,000 RPM, and then that's connected to a shaft to a set of pumps. One set of pumps runs pressure for the RP1 for the fuel, and another set of pumps, or another pump then will put liquid oxygen into the engine. So that's what the tap-off cycle is. I go into a lot of depth in that video. I promise, if you haven't watched that one, that might be one of the most in-depth and one of the best walkthroughs of all of the different cycle types. And I love that video. I think that video, I have to kind of reference some of the things. I love learning new things whenever I make a video, a long-form video. And that's one of those where I still learned a few things, especially about enthalpy, which is the relation of heat and pressure and mass flow, and all these different things, and how they actually is used throughout the system of a rocket engine. Because you do lose pressure, you lose heat in certain areas as you transfer from say, heat energy into kinetic energy, or velocity into kinetic energy, pressure into kinetic energy, all the kinetic energy. There's a lot of that in rocket engines, and I go through that in great detail in that video. So I promise it sounds scary, but it's actually really fun. So this is a good question from Donovan Stagg. Wanted to know any specific reason they are doing a retrograde launch, and what are the advantages? The advantages, actually, there aren't advantages. This is hard. This is actually harder for them technically as far as a capability of the rocket. They lose performance flying retrograde. But the biggest reason, this is a developmental vehicle. This is a demonstration of a brand new rocket that has yet to demonstrate being able to get to orbit. This is the second launch attempt ever of this rocket with this company. And flying retrograde from California allows them to fly basically as far away from populated areas as possible. So although they're basically fighting the rotation of the Earth to get into orbit, this thing's fighting, having to run upstairs, like running up an escalator that's going down. That's almost like what they're doing. It's harder to do that, but that way, that's what the company feels comfortable with for their first orbital launch attempts. That's what the range and the FAA and all the people involved in issuing a launch license, that's what everyone feels comfortable with, and that's a great way to demonstrate your ability to get into orbit. It's just simply fly as far away from any populated areas or any things of intrinsic value. So that's exactly what the teams are doing. They're playing it nice and safe, and it'll provide a really good view for us here because we'll be able to watch it come up right over, from my point of view, like right over this mountain here, and then it'll look like it'll go a little bit to my left. It'll fly a little bit south, but a lot of west, and it's going to be really cool. So this is one of our views here, looking at the mountaintop there. Man, it is very windy. We got to apologize for the wind, even though it's crazy. Even though we're on some really heavy-duty lens mounts and things, no matter how sturdy it is, the wind has a different thing to say. So, yep, whoopsie-doodle. Let's see. So this is a great question from Yo-Man. Does that mean there is no pre-burner? That's exactly right. That's exactly the beauty of the tap-off cycle, is there is no pre-burner. There is no gas generator. They literally, it's crazy. They literally just take the already high pressure from the main combustion chamber and they just pipe it over. Now the hard thing and the thing that they have to solve, some of the biggest technology that had to be developed was how do you make it so the exhaust, what you put through the turbine is an okay temperature to not just absolutely destroy the turbine. Because the turbine can only handle I think Tom Marcusic gave it to me in Fahrenheit, and I can't recall those numbers off the top of my head in Celsius, but it's something like, the main combustion chamber I think was like 4,000 or 5,000 degrees Fahrenheit, and the turbine can only handle like 1,200 degrees Fahrenheit or something around that scale. Again, I'm just talking off the top of my head. So you have to find a way to make sure that the exhaust gas that's coming out of the main combustion chamber, by the time it hits the turbine blades and the turbine wheel, it can't be that hot. It has to be cooler temperatures in order to do that. And so that's actually part of the intellectual property. That's part of the beauty. That's part of the technology that Firefly has developed in-house. And along with, originally it was with Ukrainian friends that developed some of the pump systems. There's about 200 engineers that worked on that system to be able to make the pump fed system in this that is using the tap-off cycle. Really cool cycle type. Again, it's never made it. No one's ever built a tap-off fed rocket engine, booster engine that's flown to orbit. So this very well could be the first rocket to make it to orbit with the tap-off cycle. I expect it to be. And again, it's a really cool technology, and I would love to know. I'll have to do some digging to see what options there are, because one of the ways you can cool off that exhaust is sometimes you have to dump more fuel to make it more fuel rich in just that flow of gas that goes through the turbine and through the turbine wheel. But Tom Marcusic said they don't do that. So that goes that makes me just go, how can you lower the temperature without changing your fuel to oxidizer ratio? So they've obviously developed something pretty cool by being able to come right off the manifold right there and send it right off the injector face, send it right into. It's pretty magic. I would love to learn more. So. Let's see. This is actually a good question here from Wigan Creative. Is the black paint preventing frost formation? Believe it or not, that is not black paint. It is carbon composite. It's carbon fiber. That's basically, I'm not going to say raw carbon fiber, but it is actually a really fine carbon fiber, and it's just carbon composites. You end up with all the composite, the stuff that holds it and binds it together. But if you get up close to the vehicle, you see the carbon fiber strands of it. It's not painted. It just is black because it's carbon composite, which is obviously super cool. Yeah, even in that shot, oh, you can kind of see, thanks to 4K, you can kind of see a little bit of that in the very bottom where it's kind of glinting off the sun, just a little. And actually, oh, right above you can see the clamp arm there. You can kind of see a little bit of the fibers, the strands of carbon fiber that make up the carbon fiber. You can see where the strong back is, that clamp is holding onto it. You can sort of start to see the fibers even there. That shot is going to be so cool when this thing lifts off, watching the umbilicals rip away. I mean, that's going to be amazing. I can't believe we have this in 4K. I mean, that is so cool. Oh, I'm just tickled. All right. Yes. So again, to reiterate this from Living Excuse, so if successful, this will be the first tap-off cycle ever to reach orbit. That is exactly correct. Yeah, no one has ever. I don't even know if there's been that many attempts. Honestly, I can't think of the history of that. But yeah, if successful, this will be the first tap-off cycle ever to reach orbit. That's exactly right. One moment here. All right, cool. So we're moving on here. Let's see. This is from Sway Sanchez. Why is SpaceX Vandy, or in general, what we could actually just say, why is Vandenberg so underutilized compared to Florida and Kennedy Space Center, Cape Canaveral? Well, the simple answer is there's actually a limitation to where you can fly a rocket on the West Coast. Because don't forget, when you launch a rocket, you have to basically fly over unpopulated areas. All rockets look at least in the United States, whenever they launch a rocket, they fly it over unpopulated areas. So they'll fly over the ocean. They'll close off, the marine traffic, the flight traffic. They make sure that the rocket is safe from anyone nearby. So in the U.S. you fly over the ocean. So if you're on the East Coast, you can fly eastwardly. You can fly in a low inclination orbit, meaning you can fly anywhere from about 51, 52, maybe 55 degrees. But at some point from Florida, you start actually running. If you go too far north, you start running into New York City and all those places. So you do have to fly at an inclination, an inclination. Again, if you're flying due east, 0 degrees. If you're on the equator, you would be going right around the equator. So that would be like a 0 degree inclination. 90 degree inclination would be going up and down over the poles. That'd be a 90 degree inclination. 180 degree inclination would be flying backwards, going backwards around the equator. So 51.6 degree, that's what the International Space Station is on. And that's close to the upper limit of how inclined you can fly from Kennedy Space Center without a dogleg maneuver. I have to say that because SpaceX has actually flown some really high inclination orbits from Kennedy Space Center, but they're doing that with these really big dogleg maneuvers, and because of that, they actually lose performance in the rocket. They can't put as heavy payloads into orbit. So fun little fact there. But Vandenberg has its own limitations. It can't fly eastwardly, so you can only fly basically in the polar corridors. You can basically fly polar orbits only, and or retrograde. So yeah, if you're launching something into space, you really are limited here at Vandenberg Space Force Base to what orbits you can get into. And it's just not really it depends. It's not really as common to fly sun synchronous orbits or polar orbits. They're good for Earth observation and things like that, and some communication satellites, they're helpful. But for the most part, a lot of the satellites we see are launched, if you're going out to geostationary orbit, or most low Earth orbits and things like that, and medium Earth orbits are all launched eastwardly. So you can't do that here. You'd fly over California, you'd fly over Las Vegas and Nevada, all these places. So that is not an option. And by the way, we are within T-minus 20 minutes, so we're probably getting close to the teams being able to ready to go for their second attempt. We're still awaiting more information here, but yeah, I mean, at this point we are closing in on that, so we'll wait to hear more information, and hopefully, they're obviously, the teams are always watching weather, watching all the systems at play, so we'll see how the rest of this goes. So let's see, Lab Padre, holy cow, huge thank you to Lab Padre and the Lab Padre community and all those at Starbase. It's fun being out here. I wish you guys were out here too. Thank you so much, Lab Padre. That is insanely generous. Holy crap. yeah, thank you so much for putting gas in the tank of Luna. Really, really, really appreciate that. Lab Padre knows the ins and outs of live streaming like crazy. For those of you that are space flight fans and have watched Progress at Starbase, you know Lab Padre 100%. So Lab Padre also has cameras in Florida as well, so they're no stranger to live streams. So thank you so much, Lab Padre and Lewis and the whole team there. Thank you guys for watching and tuning in. That really, really means a lot. So let's see here. Let's see. This is from Goat Pilot. Wants to know, are they using some sort of ram air to cool at higher Mach? Can we get scramjet rocket engines, please? 7,500 mile an hour cowl hood. So, no, unfortunately, for the most part, you have to realize going fast in an atmosphere is very hard to use that to cool anything. As you speed up in the atmosphere, even if it's in the upper atmosphere, as you start to compress molecules, compress air, it heats up. That's thanks to the laws of thermodynamics. So for using that to cool something off, you know, it's actually really hard to cool something when you're going at high Mach numbers and things like that. So realistically, I don't know if you can use a cowl on high-speed, hyper-speed vehicles to be able to fly and to cool things. And frankly, the problem is too, once it gets into a certain altitude and things like that, the rocket, you know, you can't use air to convect and get heat away from it. You can radiate heat when there's no atmosphere, but to use convection to cool things, you know, like a lot of us are used to fans cooling things here at sea level or on Earth in our atmosphere. We can use fans to cool things because you can blow air across it. You'll transfer heat from the object through the air. That's convection. But in space, and frankly, a much better way to do things is using liquid cooling. Because if you think about it, the rocket is actually, it has liquid propellant, really cold liquid propellant, or even the normal RP-1 flowing through the engine. Think about, I don't know if any of you have like high-end gaming computers and use liquid cooling. You're familiar with basically put up a radiator. You can flow liquid through the core of the processor and then back out to the radiator to wick that heat away. But the liquids are really good. It transfers heat very well. So that's basically what they're doing with the rocket engine. They're going to be flowing a lot of propellant from these propellant tanks into the engine anyway. So what they do is they flow that propellant through the walls of the engine first. As it's going from the pumps, and then they literally have these little channels through the nozzle and through the walls of the engine. And then that goes into the combustion chamber after that. It goes back up the wall. So kind of sometimes they do like a turnaround. They go down the nozzle, back up the nozzle. They'll cool the whole nozzle, the throat, up the walls of the chamber, and then they'll end up in the injector plate and flow into the engine from there, like a manifold and through an injector plate. So that's actually how you, and again, I have a whole video about how you cool rocket engines, because this is another one of my favorite topics, is how do you keep these things that are holding, you know, temperatures as hot as the sun inside of these walls that would melt under those conditions. But there's a lot of really cool science and engineering that goes into making that possible without making it get destroyed and melty. So yeah, liquid cooling is definitely the preferred method. But a cowl is a fun idea, but I don't think it'd be a good way to cool things. So this is a good question from Owen Medford. What is the liquid dripping from the engines, fuel or liquefying frost? So actually, I can't speak to what it is at all times, but I think lots of times when you are just seeing it literally like occasional drips, that might be just condensation coming out of the condensation developing because the engines are very cold. They have been chilled down, and condensation will develop and drip off of the engine there too. And don't forget, there's also like frost on the outside of the rocket, so some of it might be making it down the fuselage and dripping. But you will see engine bleed in at some point when I think it was around T-minus 3 minutes, they do flow and get the vehicle ready for cryogenic temperatures. Because again, liquid oxygen is extremely cold. When it hits that pump, the liquid oxygen pump, if you don't prepare that pump for all of a sudden an onslaught of really cold cryogenic propellant, you might crack or break or ruin the pump. So they have to first start flowing propellant through the engine to get it thermally conditioned for the cold temperatures. Isn't that weird? When we think about rockets, we think about the hot temperatures. We think about the crazy flames and exhaust shooting out of the flamey end of the rocket. But really, it's the cold that they have to thermally condition the rocket engine for. I think that's super cool. All right, so we do have an update that they will be moving the T0 time to, did I hear correctly? Can you repeat? Okay, they are moving their T0 time to 7 p.m. That is the absolute back end of their window now, which, if that thing flies at 7 p.m., that's going to put on quite the show because sunsets at 7:15. So if they do go right at that 7 p.m. window, it will be a beautiful, beautiful launch. So that is 3 hours from now, which means I'm going to be taking a few breaks here, so I'm not just yabbing on and on and on and on for hours and hours and hours. But we will get that updated. There we go. We already got it updated. T-minus 2 hours and 51 minutes is our official new T0 time right at the end of their 4-hour launch window. Again, their window opened up at 3 p.m. Pacific time, which I think is plus 7, so 15, 22 UTC. So now we're moving into a new T0 time at the end of the launch window, their 4-hour launch window, right at 7 p.m. So, yeah. So hopefully we hear, hopefully the teams are not working any big issues and they are able to get this off the ground today. But we will stand by for more information as soon as we know it. But yeah, thank you guys for tuning in. This is still just the absolute dream for me, just to be here. The fact that I can actually update, I love it because so many times when I'm doing launch commentary or something, there's a lot of speculation and we don't have the answers and we don't know. We're just like, well, maybe the teams are doing X, Y, and Z, and we really have no idea. But it's fun for me to actually tell you, like, yeah, they're working on, the helium pressure was the first scrub, and now maybe they're working whatever. Maybe they're looking for weather. We don't actually have the updates. I'm bragging about having information, and I currently don't have information to brag about. But the fact that we actually know the T0 time is now 7 p.m., so it's at the very end of their 4-hour launch window. So let's go ahead and I'll answer a few more questions just to, answer questions. Actually, you know what, Andrew? At some point, let's queue up. There is that video that they have about the second launch attempt. Maybe we'll queue that up. Let me know when that's ready to go to air, and I'll answer one more question. I don't remember. I think it was originally called, I don't remember what the title of that video is, but it's got Tom Marcusic in it talking about their second launch attempt. So we'll queue that video up. It's actually, the teams that make these videos are very fortunate. Yeah, I think we're getting ready to queue up that video. I'll let you know when we're good to go there. So let's see. Operator Unit 60 or 60 says, is it weird to be excited about going back to the moon? No, that's the whole point. That's like not the entire reason humans are going back to the moon, but absolutely that is a totally fair and expected thing, is to be excited that humans are returning to the moon. And again, Firefly actually has a vehicle that's going to be scouting for Artemis landing sites as a commercial lander. It's an uncrewed lander, but it's called Blue Ghost, and that vehicle is actually one of the commercial programs that NASA has enlisted to land on the moon, scope it out, see how it is as a potential landing site for humans for the Artemis program. And it's stuff like this commercial partnership with NASA, all these cool opportunities that are cropping up. I just love seeing that. I love seeing a company like this make a lunar lander that's going to help us know if a certain location is safe to land on the moon. That's really cool. But more on that in a second. Let's watch that video here from that talks about the first launch attempt and the second launch attempt.
Commit for launch.
Achieving first flight is a huge milestone for a rocket company.
3, 2, 1.
But ultimately, this business is about getting to orbit and doing it repeatedly. We did learn a lot from the first flight. We fixed the minor problems and are ready to get back to the launch pad. What has impressed me most is the growth of the team. When we tested the first flight vehicle, it took us over 18 times to get it fully functional. In getting ready for this second flight, both the vehicle and the team performed flawlessly on the first attempt. We've gotten smarter, faster, and more disciplined.
Made it all the way.
We are ready for orbit. See you at the launch pad.
And there we are at the launch pad. I think that's really cool. Again, we've talked a little bit on air about what some of the exact changes are to the vehicle, and really, frankly, they didn't do many changes. Actually, they did increase the thrust 8% though from the first rocket to the second rocket. This vehicle actually has 8% more thrust out of its Reaver engines, and that is mostly thanks to just at first you're running these engines really, really carefully. You're running them very conservatively. You do most of that with your oxidizer to fuel ratio, so your OF ratio. You hear that, and the closer, so they basically were running at like a 2.2 OF ratio at first, which is very conservative. Now they're up to a 2.3, which is a little bit leaner. It's a little bit hotter. It's higher performance though, and that's yeah. So that's how they were able to get that. They're aiming for closer to like a 2.4 at some point, and they can increase the capacity even more then. So I think they're aiming for, again, I was quoted in thrust in pounds. I don't remember if they show thrust in pounds on their website or what. They do, but yeah, they're aiming for like 45,000 pounds out of each engine. And I think they're currently now at 42,000. So they've already gone up quite a bit from their first vehicle. So good to see them continually working on things and making upgrades already. But for the most part, the vehicle itself is the same. They're just kind of tweaking and tuning the engine and tweaking and tuning some of their systems on hand just to make it, you know, more robust, more higher performance, and more production ready. I think that's kind of the big things that the teams are working through here. So let's see. This is a good question. This is a fun one to answer here. Wondering Fool, thank you for your tip. Asking, how many cameras does the team currently have set up? Also, this is a wonderful time to be a space fan thanks to the new vehicles and technologies. 100. This is like the ultimate time to be a spaceflight. It's got to the point now where there's so many exciting things, it's easy to miss things in the spaceflight world. And I think 5 years ago, 10 years ago, there were so few things going on in the spaceflight world that any launch was like, oh, there's a launch. You know, there's like 6 launches a year or something. Like, it's very, it is so easy to tune into every little thing. And nowadays, there's so much exciting stuff. There's so many new big updates, so many new things to get excited about that it's actually easy to miss some of the things. But I wanted to answer this question. How many cameras does the team currently have set up? We could do a little camera tour while we're hanging out here. This is one of our cameras on. This is kind of behind one of some of the fuel, or in front of some of the fuel tanks. There's a wall similar to the one you see kind of in the bottom right. This is the engine cam. This is a Firefly provided camera. It's an engineering camera looking at their engines. We also have beloved trench cam. This is the flame trench. This is where the when the rocket lights up, there is a flame diverter, so the exhaust will shoot out the side through this flame trench, which will, if you pull up the next shot, will also show the flame trench. But okay, we'll see that in the next shot here. We also have the teams at mission control. So we do have cameras inside mission control here. Then we have some tracking assets from the range. These are really, really, really high-end tracking cameras that track the vehicle on its way to orbit. This is another Firefly-provided camera. Is this also a tracking camera? This is another tracking camera. So we have 2 range-provided tracking assets, which are going to be awesome to be able to follow along. This is one of our cameras. That's the one looking at the strong back and looking at the umbilicals. And of course, once the rocket takes off, you will see the engines go right through that shot. We might not cut to it live on air, but we are recording, so we'll be able to have that beautiful ship footage. This is the shot, the other shot of the flame trench. So you can kind of see the yellow bits there of the railing. Down in there is that pit, and that's the flame trench. That's where when the rocket lights, the exhaust gets diverted out there, and it will make a whole bunch of smoke and exhaust, a big plume right there. That'll be a fun shot to see at liftoff. And then this is back to our first camera. So those are our cameras on the pad. We personally have 4 4K cameras. Oh, here's another 4K camera at the pad too. So we have 4 of our own 4K cameras to provide you with the beautiful views that we see here today. But then also here with us, we have a couple of tracking cameras as well on some pretty large tracking mounts. And I don't know if we'll punch those up or not, but we do have some really long lenses. This is one of them looking right at the mountain. That the rocket's going to come up right over that mountain. That's another one looking at the water tower. We use that as a reference here to know where the rocket's going to be. But that, yeah, you're actually looking through a lot of glass there. We have, when this rocket comes up over the mountain, even though it's relatively small, we'll have a really tight shot on it. It's going to look awesome. So, yeah. All right, let's keep going here with messages. Okay. What? Thank you so much to Sarah